guys, there's about, I think, 3, maybe 4 at the far outside, 5 spring manufacturers in the U.S. or in the world that I think are creditable, that build a good product. Okay. If it's coming in a box from overseas, from a Chinese company or something like that, or one of the things that I see that now we've got springs in our metric lineup that are different colors for reasons. But if you got guys that got these cars that they're making into show cars and taking them out and tracking them, and they sent their springs out to the powder coater and he powder coated them, take them and throw them in the trash can.
Green flag.
Welcome to the Blind Apex Podcast, where amateur club racers tune in to get faster.
This episode is brought to you by DeechWorks Fuel Systems. Use Apex 10 at checkout to save 10% on fueling your passion. So I'm working on measuring some stuff. You know, I'm trying to go for the Penske's this year. I've got this obtuse, weird McPherson strut Honda with weird rear springs, tiny ones. Anyway, I go on the internet to search. I'm going left and right, and I'm looking for quality springs. But when I'm looking for the springs in my size, I'm air quoting, I don't see a lot of that out there, at least not quality. I can easily find things on Alibaba, but I'm not sure I'm going to run with that. So anyway, joining me to help talk me through some spring education. He's been in the spring game for a while. He's probably got more frequent flyer miles than most people I know. I mean, he seems to be on the move all the time. Race director at Swift Springs. Frank, welcome to the podcast, sir.
Thank you very much for the opportunity today. Excited about this.
Yeah.
Education's huge. And we believe that educating the customer is just as important as having a good quality product. So that's kind of our background.
Awesome. Well, we've got a pretty decent audience here, so we can start educating folks. But let's talk about your background in springs, in racing, your experience. Let's set the stage for you.
So my title at Swift Springs is Motorsports Director. I've been with Swift now, almost 10 years. But I've been doing this spring stuff since about 2007, 2008. So I'm kind of considered the old man in the field as far as what I've been doing. I worked for a competitor for quite a while, good company, had this opportunity to come here. And Swift Springs is really, really unique in what they do. A little bit about background on me is I've been a race junkie since I was in high school. Started with drag racing and went into circle track to where I was crew chief in a car, doing stuff like that. But I drove once and I was like, man, I like the technical side of it better. There's so much there, so much to learn, and kind of a techie type. So that's what I've been doing. And honestly, I'm in the perfect place because this gives me an opportunity to fuel my passion every day of the week. So I love it. Swift Springs is a pretty unique company. I'd call us the newest kids on the block when it comes to springs here in the U.S. because we've only been here since about 97. However, the parent, the company in Japan has been around 100 years. So what sets Swift apart is we're a metallurgy company is what we do. We just so happen to make springs. So by saying that, what it does is it gives us the opportunity to really tailor make springs based on the application. So we are the only company in motorsports, whether it's street car, racetrack, whatever you want to do, off-road, that actually makes their own material. So we can control every aspect of it. We can control response speed. We can make it faster. We can make it slower. We can change so many variables. So most of us people see our website and we talk about a material called HS5TW. That's our base material. From that, we can extract or add alloys and amounts of alloys to make the spring better for what we want. Swift's actually an acronym. Most people don't know it. It stands for Springs with Intelligence from Tohatsu. And their background is road racing. That's what they started in Japan doing, and they're very dominant in Japan doing road racing. So when they came to the U.S., the opportunity was to how do we get into the streetcar market? How do we get into the racing market? And how do we build better products for the competitors? How do we give them the opportunity to make their cars faster? How do we give the streetcar guy that goes and tracks his car or does custom modifications to his car, how do we give him a better product that helps him at track day be more consistent? Racing is the way we do that. And that's what Swift's about. I attend about 180 nights a year at a racetrack somewhere in the country. I have 2 other people that work under me. There's a gentleman by the name of Bubba Gale out of North Carolina. In our industry, he's pretty much an icon. He attends about 150 nights. And then I have a new gentleman out of Idaho, Kyle Tellstrom, he's young, but he's a racer that wins a lot, and he's very knowledgeable about what we do. So we really have 3 people out in the field all the time going to races, racetracks across the country, so we can learn about the challenges the racers face and come up with solutions and ideas on how to fix them. So,
yeah, you're at a track or going to a track today. So we're recording on the weekend. This guy's not a Monday through Friday 9 to 5 gigger. He's out all the time apparently. So,
yeah, it's pretty cool. And the thing that I like about it is I tell racers and anybody that runs our product, I'm pretty accessible through social media or whatever. I understand you're at the track on a Saturday. Our racers race on Saturdays. And so they call me and I answer the phone. And the reason is they've got questions. Hopefully I've got an answer to help them. Maybe it's for a track day guy that we make his car faster. Maybe it's for a racer that we fix a handling problem he has, or he's looking for that ultimate, 100th of a second because he wants to pole. So that's why we do what we do. It's about being available for our customers to be able to help them.
Yeah, I think that's really important. But so let's talk about the feedback you're getting while you're at the track and the communication you're getting. How is that being put back into the Swift process where they're, maybe they make a change to something, or, how is that influencing what the company's doing?
Sure. Well, let me kind of start with one thing. Swift's, we actually have a technical van that I take to tracks. It's loaded with product, and it also has a spring smasher and some other equipment in it that we can actually do setup stuff for guys on their cars. But racing is a really big part. So we have a very large streetcar track time attack type following. And so how do we make cars better? Well, we go to circle tracks, and the reason we go to circle tracks is we can get a lot of laps in and a lot of data in a very short time. We're running times, anywhere from 14 to 18 second laps, and we're testing and we're putting hundreds of laps on cars. Where if we go to a road course to test, or like out in California, our guys go to Buttonwillow a lot or something, it takes 2.5 minutes to make a lap. And there's so many variables in that lap around the track that it's hard to say I made an improvement, On a circle track, because it's small, it's tight, there's a quick line around it, and then there's some other lines you're trying to find. We go and look at things like the attitude of the car. What is the response of the car? Where's the car lingering? How does it get off the corner? When we put data on cars, we have the ability, and we do that a lot with teams. We put full DTS systems on the car, And we look at throttle response, drive shaft speed. We look at shock movement. We look at frequency movement when we're doing that. And it tells us a lot about what's going on with the chassis in the car. Remember a couple things. The biggest spring that you have in a car is the chassis. So I call that the chassis, I call it the articulation device. That's what loads each corner. The only thing that touches the ground is 4 tires. So the only thing that puts any load into those 4 tires are the springs. The shocks are the brains of the spring. So you got to have a good chassis. You have to have shocks that are good, quality shocks. It's important. And you have to have a very good quality spring. Because if you don't build the load properly with the spring, you can't put the load into the tire. And in circle track racing, we look at what we call the slip angle. Slip angle is what's the contact patch with the tire to the racetrack. So by doing this, it gives us ideas on how to make cars work and stuff. One of the things that we look on in circle track racing, whether it's pavement, dirt, whatever it is how can we change the design of the spring or the chemical makeup of the spring to be able to make the car respond quicker or fix a lingering problem that the car has. So, for example, years ago in dirt car, we noticed that every time the car came off the corner, when the track got slick, there was no mechanical grip for the tire to adhere to the dirt. The cars laid on the right rear. They wouldn't get up off the corner. The car was lazy off the corner. Then it went down the straightaway and it was pretty quick. And then it got back to the next corner and had the same problem. So we started working on some stuff and we came up with a spring called the TH, which we call tight helix. That spring has more coils in it. It's of a denser material, so it has a much faster opening speed. A 200-pound spring in that style opens 18 to 22 foot-pounds per second faster than a standard spring. And then we started looking at other corners of the car going, man, rebound in a shock is your worst enemy. Because you think about, we look at a circle track, and the biggest thing we hear is, I'm really good in 1 and 2. I'm really bad in 3 and 4. Well, if you tie a car down with rebound, what happens is you're setting the camber angle of the tire to the contact patch of the track in the first corner. And because it's tied down so hard, it doesn't give it the chance to move to a different angle as it goes into the next corner. So what happens is it doesn't have compliance. Let's take that to a street car that goes to a racetrack. You're making left and right-hand turns. You're hitting a berm, you're loading the tire and unloading it. If you have so much rebound in to hold the car down, you're losing contact patch. You're losing a percentage of grip of the tire. So that's why you're good in some corners and not good in other corners, whether you go off camber or whatever. So we started looking at stuff and we started playing with things where, like in right fronts of race cars, whether it's pavement or especially on dirt, we've taken coils out of it. And the reason we took coils out of it is if we can, it's the same rate spring, but if it's got less coils in it, it's got less of an open speed. If it's got less of an open speed, you don't have to put as much rebound in the shock. When you don't put as much rebound in the shock, it has more compliance to the track. So we build really what we call for racing corner-specific springs. How does that apply to the everyday street car guy or the track guy? It gives us so much information about what we're trying to do with our springs that we take that data and what we learned based on coil count, coil pitch, spacing, and we apply it to the street car so that we can make the street car handle. I mean, a lot of guys think going around in the circles, that's not racing. Well, it is. It's a different type of racing. And guys that go and do their stuff at a track where they're going left turn, right turn, you have different challenges, but the springs, you're still relying on them for grip. So I have a good friend of mine that has he does these, I guess they're like a short course time attack. They go set up in parking lot tracks. And this gentleman has a has a Mustang. It's a very high dollar car. And they travel and go do track days. And we switched from brand X to our brand, and I kind of helped him, and I resprung the car, and I showed him why and did some things different. And we picked him up a second and a half in back-to-back testing. That's huge. But the difference was our springs didn't have the same amount of coils of what he had in his car. We resprung it different. When you have a different material, it changes the way a spring reacts. It changes the amount of grip that you have. We just did a test with an IndyCar team. It was pretty interesting. And the only reason we did it was because, not that we wanted to go IndyCar racing, we wanted to know information about our spring. What makes us better than everybody else? Or on the side that you never want to admit, where's our weakness and what do we need to improve on? So this was a real high-end IndyCar team. They came to us and we said, we're not interested. 33 cars at Indy, it's not a big field. But we thought about it and said, let's go back and ask them if they'll share the data with us. And they said, yeah, absolutely they would. So we built them a set of springs for a circle track and for a road course. And it took us a year to get all this data back, but it was really, I think, very vital. So most people don't understand hysteresis speed. Do you understand what hysteresis speed is, Con?
No, sir. You can explain it to all of us.
Okay. So hysteresis speed is how fast a spring changes direction. Now remember, a spring's a long piece of wire, and we coil it up. When you compress it, it's funny when I'm out at the track and I have a little display set up. It looks like a take-up spring, but we call it a slinky spring. It's only 6 pounds. And I put it on the table and I have people come up and say, okay, put your hand down on the top of it and push down on it. And do it slowly and watch what happens to your fingers. If you start at 12 o'clock, what you'll notice is when you compress it, your hand rotates clockwise towards the 1 o'clock position. Okay? Well, when the spring comes up, that's got to come back. Okay? So hysteresis is the amount of time or the force it takes to change directions. So, for example, if I told you to start walking and then I tell you to stop and turn around and come back, it takes you more energy once you stop to restart and come back than it did to keep going. So it's about the energy at reversal. So springs do this. Remember, most people think springs are, I'm going to use my hands like this. Most people think springs are doing this in a car. They're not. They're doing this. Okay? So that means that spring is doing this all the time. It's changing directions. That's hysteresis. The faster the hysteresis speed, the quicker it gets back to grip. So we sent this team these springs, and they tested them. And about a month and a half later, they came back and they go, well, we've tested every spring known to man. If it's got a name, if it says spring anywhere in its name, we've tested it. And they said, but we've never had the opportunity to test yours because we never built anything the size they wanted. And they said, you guys are 30% faster on the hysteresis speed than anybody. Why is that? Sat there and told the table full of engineers on a conference call, because of our material. And they said, how do you figure? And I go, we're the only ones that make the material we make. Everybody else they all say it's proprietary and it's this and it's that. It all comes from the same place, guys. I worked there. I've seen it. I know where it comes from. And so they're just using different winding techniques and manufacturing processes to say it's proprietary. That's okay. That's how they build their product. But ours is truly different because of the material. And back again, we're a metallurgic company. The next thing you need to know is frequency. So all springs work at a frequency. The shorter the spring, the higher the frequency. But years ago, when I was a kid, we were around racing, guys would take a spring and they'd drop it on the ground and it'd go ting, or you'd drop another one and go thunk. And the guys would say, well, that's a good one. The one that rang was a good one. Yeah, they're right. But that didn't tell you why they were right. We want to know why. So the IndyCar team went ahead and they They do it with frequency. We test them at 100 and at 300 megahertz. So what it does is what we're looking at basically is the tightness of the molecular structure of the material. So the tighter the molecular structure, the better the frequency. So if you have something that's porous, it's obviously not going to be as strong, or it's not going to be able to respond as quick. So they tested it at 100 megahertz and at 300 megahertz. And they came back and said, once again, we saw some amazing numbers, and we think we know why, but you averaged 24.2% better on frequency than anybody else. We're like, okay. They go, what does this equate to? And I said, grip. It's all grip. And they said, yeah, we really believe the same thing. Everything that we test and see tells us these springs are going to have more grip than anything else. So I, being kind of a smart ass, I said, well, take it out and go test it. And he goes, cost $1 million to go test an Indy car. And I was like, I didn't tell you to go run an Indy car, it's cost of doing business. And they said, well, we got a shaker rig. We got a 7-post, and we can simulate everything right there. And our data is so good, we know what it is. And I said, all right. They said, give us a couple more months. We'll get back with you. So they get back with us, and they said, we're going to test next week, and we should have answers by Friday. Are you available for a conference call? We said, sure. Friday came, and they said, we tested, but we want to retest. And I said, something wrong? And they go, no, we just want to make sure. I said, all right. So the following Friday, they called me up, and they said, look, at our level, okay, and key word, at their level of racing, which is very, very high, which is where we want to know. That's going to help you guys. It's going to help the normal guy a tremendous amount. They said we spend between $500,000 and $1 million to gain 2 points of grip on a shaker rig. Okay, that's contact to the track when they talk about grip. They said the reason that we retested was because we wanted to reset everything and retest it, and we tested it with yours, your competitors, back and forth, mixed them, everything. And he said, you guys averaged 12 points of grip, more than anything we've ever tested. They said, that's sure speed. And we were like, yeah, that's pretty cool. So long story short, we do have quite a few IndyCar teams now that have purchased product from us to go racing, which is great. But what that does is it gives us information to pass on to the circle track racer, the road course racer, the time attack racer, the hobby racer, whoever, that says, we're doing this, we're testing this, and we're finding it out to say we can make a difference in your car based on how we build our springs. Another thing that they were blown away with was they looked at our spring and they said, man, the quality of your spring is really, really nice. And we said, thank you. And they said, but you don't powder coat your springs. I said, no. And they said, what is it? And we said, well, we call it thermodynamic process, or thermodynamic transfer is what we call it. And what that means is all springs are wound soft, okay? So the material's soft. Most of the time, streetcar stuff and stuff, until we get to really big off-road stuff, it's all what we call silicon chrome. And we have many variances, like I said, formulas that we use. What happens is that material is soft. So when we make a spring, that spring is, let's say it's supposed to be a 200-pound spring. When we wind it and it's ready to go to be tempered, that spring might only be 170 pounds. Because when we put heat to it, bless you, when we put heat to it, it tightens up the molecular structure of the material and it brings it into rate. So that being said, it's a coating that comes out. So difference, when my competitors temper their springs, they do it through powder coat. So you guys all know that their springs are powder coated or whatever color. And you go ahead and they have a long line that they let the springs run down. They're hanging 3 and 4 long, and they go through an oven. Well, because of the density of the material, it takes about 450 to 500 degrees in a powder coat booth for the powder to melt and adhere to the spring. So when it traverses out of the booth, it's still very warm to the touch, and it cools off. They take it off the line with gloves, and it cools off, and they mark it, and it's ready to go. we stick all of our springs in a tempering oven. They're put on racks. The only thing that goes in there is whatever that batch of spring was. So if we made 100 of a 200 pound or a 12 kg spring or whatever it is, that's what's in there. We have a program that we go ahead and stick in there, and it goes from ambient temperature to whatever temperature it needs to be held for however long, and then slowly brought back down to ambient. And when we take it out, it's cool to the touch. That spring, we believe in all of our testing, we say that spring is tempered to the core. Okay? The other springs are flash tempered. They only see heat for a little while. Let's go back to circle track racing. Where does that come in? Just like road course racing, we can see extremely high brake temperatures. Okay? If you're on a circle track car and you're seeing brake temps in the 1,1300 degree range, on the rotors and stuff, that heat's being transferred through the suspension and into the springs. If your spring isn't tempered to the core, that spring could change. It could tighten up the molecular structure. Well, when it does that, it's going to take it out of rate. So there's a lot of things that go into it. That's why we spend so much time doing race stuff. But we learn from everything we do racing into how to make a better street car spring or a UTV spring or an off-road spring, whatever it is, motorcycle spring, mountain bike spring. This is where we learn all of it. And that's why we spend so much time, and actually that's where we spend so much money doing it, is because we're able to bring a much better, way more consistent product to our street guys and our track guys. And obviously they spend a lot of money on their cars to go do what they love to do at the level they love to do it at. And so we're not the cheapest spring, but we also feel we're the best spring. And I'm not knocking any of my competitors, but I believe that we give our customer a great value. And the other side of it is, if you have a question, you can get a hold of me, or you can send a text or an email or a message to any of us at Swift. And we got guys there that track cars and everything, and they're going to get right back with you with an answer. So you can send it to info@swiftsprings.com, and they're going to go ahead and they're going to get back to you, and they're going to answer you, and they're going to talk to you about what you're trying to do, whether it's respring your car, where you're having your problem and stuff. So there's a lot to it, and that's what we're really focused on.
Yes. I mean, you guys are the new kids on the block, like you said. Not that you haven't been in business for several decades now, right? But in the United States, but you are the spring to upgrade to when you go shopping for your coilovers. Do you want to upgrade to a Swift spring? But in the grand scheme of things, your price versus everybody else, again, it's not that gigantic of a difference, considering the quality that's coming out. I wanted to talk a little bit about, I know you guys it's all proprietary stuff, and you guys control everything, from the metallurgy side to the effects on the product, the spring itself. But I've seen springs start sagging. I've seen them lose consistency. What are the things that you guys are negating in your process? I mean, we've talked a little bit about things, but coil bind, that kind of stuff happens depending on the design of the spring and the design of the suspension setup. So let's talk about some of the things you guys are mitigating in your springs and design.
So I'll give you, one of the toughest markets for us, and this will kind of maybe help a little bit, that one of the toughest markets as far as demands on springs is circle track pavement racing. Our, what we call super late and pro late models, we're putting on the front of these cars, we're putting 20-inch tall, 5-inch OD springs that are 80 and 100-pound springs, and we're preloading them to 1,180 to 1,240 pounds of static load. that spring is about completely compressed. And then we use a bump spring. So just like your car or street car has a bump rubber in it on top of the mount, we use a bump spring because we want the car. That's actually what's setting the final grip as the car comes down. When you do that, that tall spring being compressed so long, and racers, I mean, I've got a couple of them, but I got some of them that don't, that they leave those things wound up. In other words, they take their race shocks off and put a set of travel shocks on when they put it in their trailer, and they leave them sitting there. I got guys that have run the same springs for a year and still go out and win races. And when you take that thing apart, the spring still measures the exact same length. We don't see sag and droop. Our springs are, let's put it this way. In racing, because of the level that we're at, I don't know if a lot of guys are familiar with what they call a spring smasher. A spring smasher is I can put your shock and spring on a machine, and I can chart it, graph it. I can check static load. If you told me what the center to center was on a coilover, I can give you static load. I can make a spring change, I can go 100 pounds lighter on your spring. And if I set it up in my smasher, I can put it back on the car and make it be exactly the same ride height. It's just going to have a different dynamic effect. So you can't have failures. We're using what we call a packer. It's like a 30-second shim to change the load on a spring at dynamic. And dynamic is when the car's all the way down. Okay. Static is when it's sitting there on the street, or on the racetrack. Dynamic is when it's completely at where it's at on the racetrack. We're using a 30-second packer. It's down to a 30-second packer, which is about 32 thousandths of an inch to change the load. Well, you can't have a spring that's going to sag or droop and try to maintain that and have that adjustability and have that repeatability. So once again, material, how we process it, how we temper it is all a big, big part of the repeatability of the spring and why we don't coil bind. Years ago in racing, at Circle Track, they used to coil bind, but all of a sudden they found out we don't need to do that anymore. There's other ways of racing and going fast, but we've gone away from coil bind. We don't coil bind anything. But we do look at loads, and I'm telling you, there's like on a dirt lake model, 3.5 inches of travel, 4.5 inches of travel. We go from 660 pounds of static load all the way up to almost 3,000 pounds of load in that short of a distance. And we're moving at really high speed. So all of that's really critical in understanding it. And because of what we're doing, if we had a weak link, it would show up immediately. That's why I don't spend a lot of time on the forum boards, but I'll go on there and look. And I notice guys complaining a lot about my car's sagging after a year or whatever, and this and that. And I've got, the springs aren't rating. I took them off and they're 1/4 inch short. Is this a problem? It's absolutely a problem. You may lose sometimes a 30-second maximum of a 1/16 of an inch in overall height of a spring. After that, it should never move. And it should move the first time you test it, the first time you tracked it or used it. And after that, it'll never, ever move. And if it does, the spring's bad. Take it off, get rid of it, get it off the car. If your car is dropping and you're continually having to adjust your coilover nuts to bring the car back up to the ride height you want, the spring is dust. Put it in the trash can. Okay? And I'm going to tell you what we tell our racers. The guys that Circle Track race, 750 laps, they take the springs out of the car and replace them. They're like, it's the only thing that builds grip. Now, obviously, on a street car, you're not going to do that all the time. But the street car springs are a lot heavier than a 50 or an 80-pound spring. So, yeah, it's a huge, huge part. But if you're facing something that you've got sag or droop or whatever you want to call it, and it's happening, get rid of them, guys. They're no good.
Well, I guess I'm going to have to make an order because my Voodoo rear springs, I chase a little bit here or there. Anyway, so
you shouldn't have to do that. You should excuse my expression, set it and forget it. But that's kind of the way it should be. You shouldn't be chasing your car sagging and dropping down and stuff. Guys, there's about, I think, 3, maybe 4, at the far outside, 5 spring manufacturers in the U.S. or in the world that I think are creditable, that build a good product. Okay. If it's coming in a box from overseas, from a Chinese company or something like that, or one of the things that I see that now we've got springs in our metric lineup that are different colors for reasons. But if you got guys that got these cars that they're making into show cars and taking them out and tracking them, and they sent their springs out to the powder coater and he powder coated them, take them and throw them in the trash can. You got to understand something. We know how much heat they need to see. That's part of making it. And so, yeah, you have to understand what goes on with a spring and how important it is. It's the lifeblood of a race car. I mean, besides the chassis and the 4 tires on the ground, it's the only thing that builds load. And you have to understand what it's doing. And if it's, like I said, if it's losing height, or if it's, you get what you pay for. You pay for a $39 spring, you're getting a $39 spring. You pay for a $100 spring or $120 spring, you're getting a $120 spring. There is a difference.
Yeah. There is a buy once, cry once mentality that we need to start learning. But you did say the Circle Track guys replace their springs. So how can we do a funny math and try to equate like how long a set of Swift springs could be on like a road course car? Because you know the Circle Track guys are, like you said, they're doing 4 corners every 18 seconds or faster, you know? So
yeah.
When should we start looking, or what should we start looking at in our springs and go, okay, maybe we should replace those?
So just visual inspection of your springs. Obviously it's a street car, but if you start seeing dings and chips in your springs from rocks and stuff, those can set up fracture points in the spring. Okay. So that's not a real good thing. If you got a lot of them, it's probably a good time to change them. As far as how often do you change a streetcar spring, it depends how hard you're on it. You know, if it's your everyday driver and it's your track car and stuff like that, and you put, this is hard to say. Guys will say, well, it should last 100,000 miles. It's not going to last 100,000 miles and be at the peak performance that it was. A spring doesn't lose rate. Okay. Rate is how much force you put in it. A spring loses open speed. Okay. We race and track on the rebound side of the spring. That's the opening. How fast does it open to get me back to grip? So if I told you to take a piece of metal and go like this and just start bending it, what's going to happen to it? Eventually it's going to break.
Yeah, it fatigues over time.
Right. If you have any kind of a high-performance engine in your car, one of the things that you change is valve springs. Why? They give up. Suspension springs, no different. It depends on the degree of performance you want to attain. If you're a guy that's looking for a car that he takes on the street, he likes the cool stance of it, and every now and then he'll take it out and track it, you know, in 4 or 5 years, he's not going to hurt the springs on it because he's not tracking it hard enough. If you're somebody that you have your own track car and you're out there tracking it and you're putting, you know, 500-600 miles of track time on a race car during a year, you probably, every 2 years, you probably ought to look at changing your track springs. You know, it's just, it all depends on how hard you are on the car, how heavy's the car. Okay, the heavier the car, it's going to take a little bit more wear and tear on it. How aggressive of a driver are you? Are you on the brakes? Are you hammering them? You're rolling it through the corner? There's so many variables to say how long they should last. But yeah, the Circle Track guys, we're putting thousands of braking cycles on a spring really quick, and laps. And so it's really takes a toll. Plus, we're not racing on 400 and 500 pound springs. We're racing on stuff that's way lighter. So that's a bigger part. The lighter the spring, it's going to lose its open speed faster than a heavier spring just because it's not working as hard. So, like I said, you said something, cry once, buy once, cry once, or whatever. I used to say, a friend of mine told me something. He had a racing shop that he built transmissions years ago. And on the wall behind his head, it said, buy the best and cry only once. Well, that's pretty much, it's a true statement. You get what you pay for. And I'd rather save my money up and buy something a little bit better and only have to buy it once or once every 3 or 4 years if it's something I'm going to do. A lot of guys that I know that have track cars 3 or 4 years and they're looking for something different. They're going to buy it because they want a newer model or something. So, they're never going to change the springs out on it. But it's something that's overlooked, and it's something you can't because that's what builds grip.
For sure. We're always looking to cut corners, and it seems like the easiest route, right? Because, $100 for a set versus $200 for a set seems like a spring is a spring, right? But like you mentioned before, I'm not putting cheap valve springs in my engine, right? So why would I put cheap springs on what is optimally giving me grip, right? So
yep.
It's definitely something to think about.
Yeah, I kind of embarrassed some of my short track guys into buying springs, and they said, I'll ask them the same thing I just said at the beginning is your chassis, your articulation device, that's the biggest spring that you have. That chassis has a spring rate. Why do you think you put a cage in it or do all the work to it? Because you're trying to tighten up the spring rate of it so it's more consistent. So I tell my guys at the track, I look at them and I go, when was the last time you changed your springs? 2 years ago. How many nights you got on them? 100. Okay. You won lately? No. So let me ask you a question. I go, what's it cost you to buy tires every time you come to the racetrack? Man, he says, I got to buy at least 2. They're $170 a piece. That's $340. Okay. He says, but there's more than likely I'm buying 3 or 4. Okay. How much does it cost you for fuel? Race fuel? Well, that's $13 a gallon. I'll burn 15 gallons. So, $150, $200. Okay. So every time you go to the racetrack, you're spending over $500. He goes, oh, yeah. That's normal? Yeah. Okay. I said, now, before you go to the racetrack, because we all like to have, something to drink during the day, whether it's water and a sandwich or ice, we got to go buy food, put in our cooler. And obviously, we got to have a beer afterwards. So we go buy all that. And I said, or when you're at the racetrack, you get hungry and you go over to the snack stand and you buy a burger or something. Yeah. I go, so what do you spend? $35? Oh, probably $50. Okay. If I told you that a set of springs for a race car cost you $500, and I told you at 20 nights to take them out and throw them in the trash can, your spring maintenance is $25 a night. He goes, yeah. I said, you spent more at the snack bar than you did on the spring maintenance of your race car. And when was the last time the snack bar wrote you a check for winning? And they all go, so do you got these rates on the van that we can take home with us? Because it drives a point home. Everybody thinks there's so many other things. There's a lot of things in a race car or even a street car that makes it perform. But a spring is so critical. Springs are looked like as a black hole. I put them on, set it and forget it, walk away, it's done. Depends on the level of competition you want to have. How fast do you want to go? And it's relatively cheap to replace them. And I had a guy walk up to me, races dirt late models. The purse was $1 million to win. He comes up to me and he goes, hey, Frank, you got these 2 springs? I go, yeah, what's up? He goes, those things are pretty new you got on there. He goes, yeah, they're about 8 or 10 nights old. He says, but man, he says, it's $1 million. He says, and I took into heart what you said. So he he bought some new springs. He actually ended up winning $1 million that night. So he said, he called me on Tuesday and he said, I could actually feel the difference in the car. He says, well worth the money. I said, yeah, that's good. So that's stuff like that goes on all the time. So it's about how fast do you want to go? How consistently do you want to go fast?
Yeah, for road racers, there's a lot of stuff we need to take into account, right? We're not doing 4 corners in 18 seconds, but like you said, that spring is moving quickly, right? It's not doing big full compressions all the time, though we hammer curbs, right? So it's going to compress, right?
It's going to compress.
It's going to compress, but as you move over that pavement, it's moving back and forth in a smaller manner, but it's always moving, right? So
springs are always moving, always moving.
Yeah. So I think they're overlooked. This conversation has sort of opened my eyes. I mean, I'm in the market for springs anyway, because I'm trying to get these to work the way I want them to work, and fit where they need to fit. Honda made this dumb McPherson divorced car where I have like a 4-inch spring in the back. It's the most ridiculous thing I'm fighting right now. I'm not really fighting it, but I'm on a spring that's, I guess I have to go a little bit taller, but anyway.
If you can always try to work towards the shortest spring that you can, just because of the speed of the spring. So I'll ask you a real simple question. And then you can, maybe the people out there listening can understand it. How many people think a spring builds load from the outside in or from the inside out? Pretty simple question.
I mean, I would assume it's outside in, but no, probably wrong. I don't know.
You're not alone in that answer. It's not the right answer. Springs build load from the middle out. And if you compress a spring, like we have a smasher, so it's easier to see, obviously, than it is trying to watch it in a camera or something in your car. The center of the spring, the center coil, never moves. You compress everything towards it. So the top and the bottom move towards the center. So the spring builds its load from the center out. And the other thing you need to remember is a spring takes an inch of travel to get to rate. So if you have a spring that's a 100-pound spring, I'll break it down to a 100-pound spring because that's the easiest way to do it math-wise. And I told you, and I graphed this stuff, so I'm pretty sure I'm on track with what I'm telling you here. If I take and look at that spring and I break it down into a 32nd of an inch, okay, it's going to have 30 seconds, right, to be a full inch. So that means for every 32nd of an inch, you think that spring, if you divided 32 into 100 pounds, that means that for every 32nd, it should move 3.3 pounds, which would give us 99.99 pounds when we're all said and done. Well, when you start compressing a spring, you'll notice when we graph them that spring is not in the first 32nd, the next one, all the way down to at least probably close to a half inch. It's way shy of 3.3 pounds per 32nd because we're activating all the coils as we're pushing them together. Once you get over a half an inch, now you start to see it ramp up to where when you're now in the last quarter of an inch, now you're starting to see it really stabilize and get to that 3.3. But there's a point where you have to collapse it to get it to rate. Well, you're pushing the coils to the center. So obviously, if I have let's say I have an 8-inch spring in a car that's got 8 coils, and I got a 4-inch spring in the car that has 4 coils, a 4-inch spring is going to move way faster because it's got less coils. It can be the same rate, but it doesn't have to compress as many coils to get to rate. Make sense?
Yeah. So, okay, that makes sense to me. I get it. My problem is I'm topped out on my adjuster. So I can't raise the car any higher without more length. So something's got to give.
So something's got to give. Yeah, you got to have a taller spring, drop the bottom nut down or something to get you more stroke. The best way to do it is, how much stroke do you have in your shock?
I forget. It's enough.
Measure how much stroke you have, because you don't want to top it out either.
Well,
You know what I'm saying?
it's a divorce setup, but yeah, I get it. I don't want to top out that. I won't. Trust me, there's plenty.
Okay. Yeah.
So,
But and stay with the shortest that you can do to achieve the goal you want.
yeah,
It'll make it quicker response on track day. I
could measure and just go, oh, I could fit a 6-inch in here and make it work. But in the end, a 5-inch may be better because I'm on a 4 right now. So I guess the next step is a 5-ish.
Yeah, we make them 5.
Yeah. So.
What kg and stuff is. So yeah, one of the other things that road racers do, or guys that, take your car out and time attack, road race, whatever you want to call it. One of the other things that you guys use is a lot of tender springs or helper springs on the top. And I get asked a lot, which one should I use? And remember, those were actually made because you said it earlier, you guys hit berms, right? Well, when you hit a berm and the car comes down to full droop, a lot of times that spring unloads itself and it's completely free. So what the helper's there for is to hold it, okay, so that it doesn't fall off the perch. Basically, when it comes free from the perch it sits on, if you hit the berm hard enough. So I tell people, look, if you think that spring is unloading, okay, what you need to do is you need to put a helper spring in there to keep it loaded. Otherwise, it takes too long to get back to grip. And they say, how do I know what rate to put in there? Well, depending how far you're coming off, the heavier the rate, the helper spring, the faster it's going to close back up. Remember that helper spring, when the car's sitting at ride height, it's completely compressed. It's just like a spacer. So all you're using it for is when you hit that berm and it comes off the berm to help it reload the spring as fast as you can. It's because it's always basically at a solid position when it's on your car. So that's an easy way of understanding how to use it and when to use it. Guys also say, man, and this is something we do in racing, and it's pretty simple. I think it's pretty cool. Remember, what you're doing with your car is you're racing it, and you're racing it at dynamic. Okay? Dynamic means that where's the attitude of the car when I'm going around the track? Static means where I'm sitting there taking a picture of it. Okay? Guys don't understand how far they're moving their spring. So there's a real simple, easy way to do this, and all you got to do is get yourself one of these big wide Sharpies and color the shaft on your shock. Wipe your shock shaft off and reach in there and color it. Okay? When you color it, and might have to push your bump up to make sure you color underneath it too. You can go ahead and when you go around and do your lap or two and come back in, it's going to wear off the Sharpie. So now what you do is you go ahead and you say, okay, I got a 6-inch spring. It wore off 3 inches of it. Okay. And then you lift the bump up to see if it was into the bump any. If it's into the bump, you figure out how much into the bump it is. That's going to change something for you, but I can't help you without a machine. But pretty much simple, you can say, let's say it's a 400-pound spring and it moved 3 inches. Okay, if I was set, let's say the spring's a 6-inch spring and it's 400 pounds. And when the car is sitting at static, the spring is 5 inches tall. You measured it. You got in there and measured it, okay? That means that spring has 400 pounds in it, right? Now you go out and you track it, and you come back and you notice that it's wore off another 1.5 inches. So you take your 400 static, and 1.5 inches means that it loaded it another 600 pounds. That means your dynamic number is 1,000 pounds, okay? Once you can do that, it's pretty simple math to do. You can convert, a lot of guys don't know it, but take your kg of your spring and multiply it times 5.6, and that'll get it to you in pounds. And when you do that, now you have a way to tune it. Because if the car's loose, that means that you have too much load in it. So maybe it's a spring change. Maybe if you're on coilover, it's an adjustment nut. rate, but that's going to change the ride height of the car. So it's probably a spring change. If the car's tight, it means that I don't have enough load in it. Okay. And putting more load in it means I'll free it up. So it's a way to start to track tune a little bit by understanding how far it's traveling and what your dynamic number is. Everything is based off dynamic. So that kind of gives you an idea of a simple way to figure out how far am I traveling? How do I make my car better by not having to go out and put data and all this other stuff on it? You know, we call it Bubba calls it the Alabama travel indicator. Just use a Sharpie and put it on there and it works great. So it's a real simple way, but I mean, we do it in dirt track race. I had 4 or 5 guys doing it last night when we were racing, just trying to figure out where we had and if we need to make a spring change. So it's a pretty cool way. There's always a way to do something. And remember, the more data we get, the better tuning changes we can make, especially a spring change or whatever we need to do to make the car better.
For sure. For sure. Well, Frank, it's been a pleasure. We're almost to an hour. So I wanted to thank you for coming on. I want to thank Trent publicly for hooking this up and reaching out to you and getting this thing set up. So is there any other closing comments you had? I'm sure we could be here for another 3 or 4 hours.
I do seminars and they go 2 days, but I'll be honest, it's, it's education, guys. And the biggest difference, Swift, I think, I'll put our springs up against anybody. We've done it. We come out on top. But the biggest thing is you can build the best product in the world, but if we don't educate people on how to use it and what to look for, they become frustrated. And the next thing they say is the keyboard warriors are out there banging away and they're saying, oh, you should use this spring because it's better because I know this and that. There's very, very few people out there that understand coil springs. It's the black mystery hole of racing. And there's simple ways to do it. We're available. We love talking about racing, talking about your car and how we can make it faster. And that's what separates us from everybody else. Have a great product, have great technical support and great customer service. And that's something that Swift Springs, that's us. If you looked at our mission statement and our motto and our creed, it's about those 3 things. And like our owner says, we can build the best spring in the world, but if we don't educate the people on how to use it, we're no better than anybody else. So we're here for you guys. And thank you again for the opportunity to do this. It's been a pleasure. And hopefully we answered some questions for some people. And like I said, reach out to us. That's what we're here for, man. And we love it.
Awesome. I appreciate you, sir.
My pleasure, bud. Take care and have a great day.
You too.
Until next time, keep working on yourself, keep working on the car, and let's get faster.